This conference will now be recorded.
Hi everyone. Thank you for joining in, and thanks to JS Lovers for giving me an opportunity to organize a workshop. So I'll be starting off. The workshop is dividing into two parts. So one is the theoretical part, and second is the hand-on coding. So we'll be first doing the theoretical part, and next we'll jump to the coding, and you will be doing along with me. So I would request everyone to clone the repo, which is mentioned in the chat, and install the dependencies. So it would be easy for you to follow along and code with me, and you'll be able to learn more if you code along. So yeah. So I think let's begin with the presentation. I'll just share my screen. Is my screen visible? Yeah.
Yes, Apurv, it's working.
Okay. So yeah, let's begin with the workshop. So just a small introduction about me. I work as a front-end engineer at Razorpay. I love building side projects. I keep writing blogs about my experience at different companies I've worked in past, and I build projects. I like to create memes sometimes. And in case you have any queries regarding the workshop or anything else in general, you can reach out to me on Twitter. And even this is my first job at Razorpay. In case you are a recent graduate or still in third or fourth year, if you have any queries, you can reach out to me on Twitter. So before jumping on directly to what exactly Babel plugin is and why do we need it, so I want to give a small just details about how web page gets loaded in the browser, because it would be easy for us to follow along and understand most of the concepts, theoretical concepts which are getting used when we are building Babel plugin. So what happens is when you generally load a web page in the browser, so we all know the DOM is created, right? And then CSS OM is created, which is CSS object model. So when DOM and CSS OM is created, they both combine and form a render tree, right? So render tree is just basically a mixture of DOM and CSS OM. And right, once the render tree is created, right, nothing is painted on the screen as of now. Just a tree is created. After the render tree process is completed, we have the layout step. So what exactly happens in the layout is whatever needs to be displayed on the screen or printed on the screen, basically, the information is generated in the layout step. The pixels, the position, and everything related to that gets created in the layout step. And the next step, which is paint. So basically what happens is nothing is painted on the screen as of now. Everything is just happening in the calculation phase. In the paint screen, what happens is we have different layers of layout. So sometimes you will see there's an animation going on. So there's a different layers. We know that if the div is moving from 0 pixel to say 30 pixels, so there are different layers happening, like 0 to 1, then 1 to 2, then 2 to 3. So these are the different layers. So everything, all the layers gets combined to each other, and this process, and this happens in the paint phase, the layer combination and generation of different layers. And since after this step, nothing still this step, nothing is painted on the screen. After this step, what happens is compositing step. So what happens in this is the layers which were generated were sent to the GPU, and when these layers are sent to the GPU starts painting them on the screen. So this is how a normal if you have a set of HTML and CSS, that this is how it gets displayed on the screen. And this whole path from DOM creation to compositing is known as critical render path, right? So there are different steps involved in it, and the major steps which we discussed were layout, paint, and compositing. You can read more about it on the internet. We won't go deep into this because that's not the scope of our workshop. But yeah, this will be important to us. And now we have seen like how HTML and CSS gets parsed and displayed on the screen. Now we have something how JavaScript gets compiled. This is something which is very important to us in the workshop, because indirectly Babel works on compiling and transpiling JavaScript, and this is something we'll be working on today. Suppose when we have a JavaScript file, and when it gets loaded into the browser, let's say Chrome, Mozilla Firefox, Safari, anything. So whenever that JS file gets loaded, it gets converted into AST. So AST is something which is very important to us throughout the workshop, because we'll be playing a lot with that. So converted to AST, and once it's converted to AST, it is sent to the compiler. The compiler which is present in the browser itself. Let's say if we consider Chrome. So Chrome has V8 engine, right? So that AST is fed into the compiler. Compiler is does a lot of job. Okay, so compiler makes our code more performant, and as per its needs, it removes the unused variables. V8 engine especially removes the unused variables, and so compiler in altogether is something very different. It's a vast topic. We won't deep dive into it. And once it has made our code more performant and converted into the bytecode. So the bytecode which is generated from the compiler is sent to the CPU. And once it is sent to the CPU, the code which we have written gets executed. So the major step which we'll be focusing on is the second step, converted to AST. So this is our whole focus today, converted to this AST step, and I'll be talking more about ASTs, what are ASTs, and how we'll be playing around with it in this workshop. So what is AST? So AST basically stands for Abstract Syntax Tree. Some of you might have heard about it and will be have a good knowledge about it. But in case you don't have, I'll be telling you in detail what exactly AST is. So whatever language you write, irrespective of anything, like even MySQL, PHP, Python, JavaScript, anything you write, the code which you write is just a string, right? It's just a normal English which you write. It's just basically a string, and compiler can't understand it, right? Obviously. So for that piece of string, for that compiler to understand that piece of string, it needs to be converted into something which called AST. So AST is basically a string representation of our code which we have written. For example, if you see, we have function sum which returns 1 plus 2. So when this piece of code gets converted into AST, it would look something like this. So it has all the details about our function. So it has function declaration, it has the body has the block statement which we can see, and in the body there's a return statement, right? So there's a return statement. So it has all the information. And if you're wondering how did I generate this, if you're not aware of this, so there's a website called astexplorer.net. So if you want AST, if you want to generate AST for anything, so you can like just write it here, and it will give you the abstract syntax tree of everything. And there are different languages which you can say, as I said, PHP is there, Python is there, SQL is there, so you can convert it into AST. This is something a compiler will understand, right? So we'll be playing a lot with this. The whole Babel plugin is all about playing around with AST, manipulating it, and it is something really interesting. So yeah, uh, yeah. So before AST, there's a concept called parse trees. These topics are not just based on one language. It's based on every language. It is true for every language which we write. It is basically a computer science topic, like it's a general computer science fundamental, parse trees and ASTs. So before ASTs gets generated, like there's something called parse tree. Parse tree is something which is more detailed form of AST. It has information even about the white spaces which are there in a code. It's the comments, the semicolons, all the extra information which we have in a code is in parse tree, right? So whenever the code which we write is fed into a compiler, so it first generates a parse tree, and then parse tree gets converted into AST. So the question is, why can't we work with parse tree? We can. There's no need of AST. We have the tree representation, and compiler can directly understand parse tree. Let's work on that. But the main problem is parse tree has a lot of extra information which we don't need it. It increases the size of tree. So if you compare this equation which we have, 2 into 7 plus 3, if the same equation is written into parse tree, it is something this. So there's a 2 and there's the expression which is connecting 2 and 7 is the multiplication sign, and which is connecting 2 into 7 this is the plus sign. So the plus sign is the parent node, and 2 into 7 and 3 are the child nodes. So this has a lot of extra information, and we don't need it, like whether plus is an expression or what. So when this parse tree gets converted into AST, it is converted into something like this. This is a small version, smaller version. It occupies more, it occupies less memory, and it's more performant. So this is something. This would be easy for a compiler, and it would be faster to execute this code, compile this code. That's why a parse tree gets converted into ASTs. It's not necessary for all the compilers to first generate AST and first generate parse tree and then AST. Some compilers directly generate AST. It is specific to compiler, but yeah, before the AST generation, parse tree definitely happens. Some compilers might consider it as two-step process. Some compilers just consider it as one step and directly give you the AST, directly throw AST as an output. So this is a detailed description about parse trees and ASTs. So just to repeat over, we use ASTs because they occupy less space and are more performant when compared to the parse trees. So I think this is a basic information which we should have before we jump into Babel and why do we use it. So you might be aware about Babel, the fact, and all the depth tooling things which are present there, right? So in case you're not aware about Babel, so Babel is basically a compiler which is used to transpile our JavaScript into something which our older browser will understand. Which basically converts JavaScript, which older browsers won't be able to understand. And it is a lot more than that, but the basic definition is just it helps us in transpiling the JavaScript into something which our older browser would understand. So just to give you a small idea of what exactly it does is, if you're not aware of it. So if you have cloned the repo which we are working on, the repo looks something like this. In the src folder, I have one file. It's fine if you don't want to follow along with this, but we'll be coding all these four. But yeah, this is just a small introduction in case you want to see what happens. So basically, there's an arrow function, right? And this is something ES16. This syntax is ES16. So some browser, the older browser, might not understand what is arrow function. So we need to convert that to a regular function expression. So Babel will help us in doing that. So there's a file called babel.config.json. What it does is it has targets where we want to which format we want to. So the Chrome browser 58 and Internet Explorer 11, we want these browsers to understand that this is an arrow function, and we need to convert that into a regular function. So if we write something like npx babel src, right? Yeah. So this function got converted into a regular function. So these both are exactly same, but for the Chrome version 58, the it won't understand the arrow function. The arrow function got converted into a normal regular function. And just to give you a bonus thing about it, we'll be doing it on our own. We'll be converting an arrow function into a regular function in task 3, I guess. Yeah, we'll be doing it. So it would be really fun to code along how this arrow function gets converted into a regular function. So this is something, just a small description about Babel. So how Babel actually works. So this is also important for us to understand because we'll have to somehow integrate our plugins. We should know at what point Babel will actually use our plugin. So to make that Babel understand where do you want that plugin to operate, we should know the steps involved when the Babel starts compiling our code from higher JavaScript to the lower JavaScript, which should be easy for the browsers to understand. So the first step is parsing. So parsing is basically when the code which we write gets converted into an AST. This is a parsing. So parsing has basically two steps involved. One is lexical analysis, and second is the syntactic analysis. So all this is a theoretical part, but you should have a good idea to build a Babel plugin. So the first step is parsing. Whatever code we write gets converted into an AST, right? Irrespective of if you mention a Babel plugin or not, this will happen. The Babel will transpile your code. The Babel will convert your code into an AST, right? And after this step is the transform step. This is the step where our Babel plugin actually operates. In this phase, we'll transform our AST. So Babel plugin is all about transforming your AST and converting one piece of code into something other. Right. So this is where our Babel plugin will operate in the second step, where we'll manipulate our ASTs, update it or delete anything. And the third step is generate. We'll generate our code. We'll generate a code from the AST which was modified in the second step. So once our AST is modified in the second step, we'll generate it into back to the code which we got in the first step. Just to reiterate over the steps which are actually involved, parsing is basically conversion of code into an AST. Second step is modifying and updating that AST. And third one is once that AST is modified or not, generate back the code, right? So these are the steps which are actually involved. And we'll be working on the Babel plugin operate on the second step. So just to give an idea, where will our plugin operate? So that's a transform phase. So let's work on some real examples. But before we do that, there are some useful libraries by Babel which we should know about so that it would be easy for us to understand. It would be easy for us to code a Babel plugin because there's a lot of utility libraries provided by Babel which reduce a lot of manual coding. And the ones I've highlighted with blue are something which is very important to us, and we'll be using these. Others are also important, the two parser and generator, but the major usage will be of these three. So what is Babel parser basically? So what Babel parser does is it converts, as I said in the first step of parsing, it converts our code into an AST. So whatever code we write gets converted into AST. So just to give you a small demo, can do it along with me. So there's an API folder in the repo which you clone. If you go to that, there's a file called Babel parser. So we'll convert that piece of code into an AST. So the AST would look very similar to this, very similar to this generated here. So if I do something like node API, so yeah, this is the AST which is generated. This piece of code got converted into an AST, and this AST is very similar to the one generated by this AST Explorer. So this is very useful because we need our code to get converted into an AST. What is Babel generator? So if you remember the last step, which is generate, this converts our piece of code back in this converts our AST back into the piece of code we want. So once we have transformed our code and manipulated it, so we need to convert that code back. We need to convert that AST back to the code. So Babel generator is used for that. It will convert our AST back to the code. Babel types. This is something really interesting. If you go to this AST Explorer and if you see this function, so there are different type of there are different types in AST. So if you see this, the type of this is function declaration. Okay, this is something this is a function and this is described by a type which is function declaration. And if you go to the body, this is a block statement, so that's a type. So every node has a type in Babel. And if you see the return statement, the type is a return statement. So everything in Babel would have a type. So and if you let's say declare a variable, so const temp is equals to 1. Right. So that's a variable declaration. The type of this is variable declaration. So everything which you write when it gets converted into NST would have a type to it. So if you see temp, it's an identifier, right? And if you see the 1, which is a numeric value, it's a numeric literal. So everything would have a type. Okay, so Babel types is something which helps us to identify if that is a particular type or not. So either you can do something like if you want to see if it's a numeric literal or not, what you would do is you will go to the declaration object and then you will go to declaration.init.type. If it's equal to numeric literal, you'll know that it's a numeric literal. But that's something like you will have to deeply nest into an object and see if that's an object or if that's a numeric literal or not. So what Babel types does is it provides us a very small functions which help us in understanding if it's a particular type or not. So suppose we have this function sum, right? And this is a function declaration, right? As we checked before, this is a function declaration. So how will the Babel know if it's a function declaration? So if you go to the Babel types, the plugin, and if we search for is function declaration, so there's a utility function which is function declaration. So it will either return true or false. So if we pass that node into is function declaration, it will give us if it's a function declaration type, the type of that node is function declaration, yes or no. It will just output true and false. So it is very easy to check what's the type, and we can create if suppose we want to create a function declaration, so we can just this is function declaration. So this would create a node which will be very similar to function declaration. So we'll use this in the next task. So it's fine if you're not getting a good hold on it, what is it exactly, but just to give you an idea, it helps us in uh, uh, it helps us in knowing if that particular node belongs to that particular type or not, whether that node is a function statement, or you can say it's a return statement. With the return statement, it helps us in checking. It gives us the Boolean value. So this is the use of Babel types. The second one is Babel template. So it's very similar to the template strings which you use in JavaScript. So just to give you a small idea what exactly this is. So there's an API in the API folder. If you go to the Babel template, so there are two examples in it which I have written. The first one is this, right? If I run this file, which is node API Babel template, right? So what happens is ignore this console for a while. So what happens is template has a function attached to it, which is AST. So what it does, it converts that piece of code into an AST. So this is our AST for this particular function, and this is the second console, which is let temp is equals to 2. It is very similar to how template string works in JavaScript. So suppose I have a build variable function, and I have written let variable name is equals to value. Now I want to manually pass the content of variable name and value. What I've done is I have passed this the parameters in the build variable. I want that variable name to be an identifier of type temp, and I want the value to be a numeric literal, which is 2. So what happens is when this file gets executed, the variable name will be assigned to temp, and the value will be 2. So if you see the console.log for this, the code generated in the end, once this file is generated, we'll have let temp is equals to 2. This is what happens. It's just a basic template string template literal which is there in the JavaScript. But yeah, so our variable name and value we can pass as per our need, and the different things if we want in a Babel plugin. So this is the use of template literal. There are different properties attached to it, but the basic one are these ones, which will be helpful for you. And then next is Babel traverse. So a traverse is basically when we want to traverse our AST to manipulate it. It's basically used for updating and modifying, deleting nodes. So Babel traverse would be used in that. It's nothing very complicated. Just that you can Babel plugin is all about, as you know, modifying the AST. So Babel traverse will help us in doing that. So I guess that's all for the useful Babel libraries. This is the last theoretical part, and after this we'll start coding. So don't worry about all the theoretical concepts. You will gradually get a good hold once we start coding. So a few important concepts is in Babel plugin is visitors, path, and state. So visitors is something. For example, you're visiting something. Suppose you want our Babel plugin to operate on, let's say, function declarations, right? So we want that Babel plugin to operate on function declaration. This is a kind of a visitor. So we want that Babel plugin to visit that function declaration and execute whatever the code we have written, manipulate it as per our need. And so visitor is basically like visiting that particular piece of node. It's nothing complicated. Just just describing where we want that Babel plugin to visit. Paths. Okay, path is something which connects two nodes, and it's basically a link between two nodes. And once you visit a particular type, let's say if you visit a function declaration, you can access all the properties. All these nodes are linked to each other with the property called paths. So we'll be seeing what exactly path is, and we'll get a good idea about it. And state is something which you pass in the babel.config.js file, which we have here. Sorry, Jason. So if you want to pass an option, let's say if you want to pass something like option 1 is equals to true, right? You want to execute code on basis of some option passed by a user. So how do you access these option 1 in the AST which you are writing? So this would be accessed with the help of state. So if you do something like in the visitor which we'll be writing very soon, so if you do state dot options dot option 1, we'll have this true parameter with us. So it will be useful for us if you want to manipulate it. If you want to have some checks, we can access these properties, additional properties with the state object. This is the use of state. So this is all about the theoretical concept. Just to reiterate once, visitors help us in visiting a particular type. Path is basically a link between two nodes, and state helps us in what do you say in accessing the properties, additional properties which we pass in the plugins. So all these properties can be accessible using state dot options. So this is the use of state. So now we have got a good hold of all the what we say basic theoretical concepts which are needed in constructing in building a Babel plugin. Now we'll start building the Babel plugin. So I hope all of you have cloned the repository, and if not, like let's wait for a minute and just clone it and install the dependencies. And after a minute, we'll continue writing our first Babel plugin finally. So let's wait for just a minute. In case you have like some doubts, we'll definitely cover most of them in the end. If you're facing some issues with the conceptual things, whatever we have discussed. Uh, Apart from that, we'll start just coding in a bit. Our first Babel plugin. We'll be working on 4 tasks, and I hope you will really learn in these 4 tasks, and you'll be finally able to create something on your own. So I guess we are good to go. Uh, I think most of you might have cloned the repository. So let's start working on it. So so navigate to the src folder and open a terminal by side in your side so that you will be able to execute the commands. So the Babel task 1. So in the task 1, what we'll be doing is, if you read the statement is in the task we'll be removing our console.log from our code with the help of a Babel plugin. So suppose we all write console.log for debugging and checking what are the outputs or not, and sometimes we just forget to remove them from our code, right? And those goes into the production, and obviously the we are reviewed, but sometimes it gets missed, and we don't want that console.log to here. So what we can do is we can integrate our Babel plugin, which will remove our console.log from the file from wherever it is present. So I think this is something which can be of a good practical use when you are like working in a big project and you somehow missed removing console.log. So I hope you all have this boilerplate setup. It's just a small setup we have imported required Babel in it, and this is the piece of code we'll be working on. And here we'll write our first Babel plugin. So let's name our function, which is function remove console.log, and let's write it here. Right. So we have written, we have mentioned our plugin, and we'll be working on this function. We'll be writing everything inside this function. So as I said, we need to define where we want to operate this, Babel plugin. Okay, just a second. Sure. Okay, I guess it's something, yeah. So if we take that piece of code and check it on our AST Explorer, so this is, we have to target the console.log, right? Where this task statement is, we want to remove the console.log statement. So if we just see the console.log, if you can actually like hover on different things and it will tell you what are you targeting. So if you click on the block statement, it will highlight the block part. If you go to the return statement, highlight the return part. So let's go to the console.log part. So if we see, it's an expression statement, and inside that expression statement we have a call expression, and the type is call expression. So now we know we have to target the call expression. We have to we want our AST to work on that call expression. So we'll copy this call expression, and what we'll do is we'll return an object which will have visitor. And I already told you what visitors are. It helps us in visiting a particular type. And in this case, in this example, our type is a call expression. So we want to visit a call expression. So we'll write call expression, and we'll work on this. Right. So this is something. I hope we all are on the same page. Just to reiterate, this is our Babel function, and we want to return an object which will have a visitor property, which will tell where we want to visit, where we want that AST to operate on, and we want to operate it on a call expression because our console.log is a type of call expression, right? So if we see, it's a call expression. If we hover on this expression, then we want to remove that whole console.log. So this is something we want to operate on. So now, as I told, there's a second thing which I explained in the slide, which was path, right? So path helps us in connecting two nodes or modifying a thing. So the parameter which would go inside this call expression is path, and the second parameter is state, which is something which I told you, like state allows us to access the options which are passed in the Babel plugin. So the second parameter would be state. That's how we can access our other properties. So now what we want is we want to remove that console.log. So path has a default property or default function on it, which is remove. So if we do something like path.remove, right, this will remove our call expression, whatever call expression is present. So if you run this, if we do node src babel task1, right, and if we see the output, I hope I don't get any errors. It's taking some time. Yeah. So this is the function which we wrote, right? And the output is this. So we have removed the console.log finally from this, right? It was super easy, nothing much of brainstorming or something. If you write a second console.log, let's say hello, right? And if you again run this, it removes all the console.log. But what if there's another call expression which is not console.log? Let's say there's a function called other function, right? And if you check over the other function, that is also a call expression. Like, what if that function is really important to us and it's not a console.log statement? but it's of type call expression, right? We don't want to remove this, right? But what is happening now is it will operate on all the call expressions which we have and will remove it from the code. But we don't want to remove the one which is not console.log, right? So just to give you an example, if we still have console.log comma b, and if we have other function, I haven't declared other function, but yeah, it doesn't matter because we're not executing code now, we are just compiling it. So if you do node src Babel task 1 in JSI. So what happens is it has removed the other function. Like we don't want it to remove it. We have to somehow just remove the console.log. So what we can do is we'll just check if the call expression, if we see our AST, in the call expression, there's a property called, okay, if we see the, yeah, in the call expression, if we highlight over the console.log, in the call expression, there's a property called callee, and callee there is an object property which has a name console.log. So that's how we'll know that if our path.node.callee.object.name is console, then only we have to remove that. Otherwise, we don't have to. So right, this is something like deeply nested, like callee.object.name is console or not. So this is where Babel types come into picture. So what happens is we'll import Babel types. If you have installed the dependencies, you would already have them, have it. So you can just import it like this. Right. So what you want is you don't want to remove this other function, right? So we'll just have to somehow check if that call function can name is call expression can name is function or not. So what we can do is we can check if, so this types, as I told that we can check what kind of type it is, right? So I'll check types dot is identifier, and we want to check is path dot node, what was it, path dot node dot callee dot we want to check on object property, and we want to check the name, right? If we want the name to be console, if it's just that, we'll remove it. So we'll check if the name is console or not. If that's the case, if this is something which are matching our conditions, we just want to remove. Otherwise, we don't want to remove it, right? So I'll just reiterate what we did. We are just checking if the call expression's name is function or not. So how we can do is if type is identifier. So if you go there, the type of this is identifier, right? We want to check if this path.node.callee.object is identifier or not. We'll check if path.callee.object is identifier or not. If it's an identifier, yes, it's an identifier, we'll just move forward, and we'll check if this identifier has a name property which is console, right? This is something which we want. We want that part to be removed from our piece of code. So if we run this, this has removed the console.log, and other function is still there because the condition doesn't match. The name is not console in the second part, and it was there in the console.log a comma b, so it removed it. So this types is really useful. It helps us in understanding if it's what's the type. Otherwise it would be very difficult for me, because if I would have not used type, I would have to do something like path.node.callee.object.type is equals to identifier, sorry, whatever the spelling is, and if it's identifier, and if path.node.callee name is console.log. So I'll have to check first if it's an identifier and if it's the name is console.log. So it would be a lot of code, right? So types helps us in just identifying. It will just give us true and false if it's an identifier or not. So this is how we can remove a console.log. I hope you all understood what we are doing and we are on the same page. So just to reiterate our things, we targeted the call expression. we checked if the type is identifier and the name is console.log. It's just console. We'll remove that path. This is a first plugin, and if you want to publish it on the npm registry, just export this function and publish it a normal npm module, and it will be a first Babel plugin, and you can use it just by specifying it in the Babel config file as an array in the array, and this will be a Babel plugin, and this is how you can remove console.log. So I hope you like this task one. It was just a basic task. Now we'll be working on something interesting in the next task. So if you open the Babel task 2, so and if you read the statement is in this task we'll change the n. The n is basically the params which we have passed to any other variable using path properties. So what are we doing in this task is we have a variable n, we want to convert into another variable. Let's say we want to convert it into a. We want all the n's to be replaced with a, right? So we'll write a Babel plugin. So I hope you remember what we did in the first task. We'll first write our function, which is function change change params name, let's say, right? And we'll just call it here, right? This is right. Now we'll just return it. And as I told, we'll write visitor as always because we need to tell where to visit. Now we'll put the piece of code into an AST Explorer. Let's put it into an AST Explorer and let's see where we want to target. So we want to target a function declaration. So as this is a function, we want to change everything inside this function. So the target this time, instead of call expression, which was the last time, we want to target a function declaration. So we copy this function declaration here from here, and let me just move it here. Yeah, so I just copy that function declaration, write it here. Now we want to target a function declaration, and as I told you, the properties which gets passed into is path, path and state. Oops. Yeah. So this is the property we want to pass. Now we want to change this n into, let's say, a. So what we can do is we want to change the scope of all the n's which are there in this function into an a. So what we can do is path has a property called path dot scope with the n's which are scoped in this path dot rename. We want to rename all these properties is something which you can explore gradually. There are a lot of properties which are present on the path, and once you start developing plugins on your own, you will get to know all the different properties which are present in the path. There are a lot of things: path.get, path.remove, path.scope. There are a lot of things: path.reverse. So you will gradually get a good hold on them. But yeah, we want to rename it, and what we want is we want to remain all the n's into, let's say, a. So it will target all our n's and convert it into a. This is what we want, right? We wanted all our n's to convert it into some other variable. So if we run this, which is node, and if we do Babel task 2, it's not there. Oh, it's an src folder. Yeah. Okay, there's no semicolon here, my bad. So if we do node src Babel task 2.js and we run it, we'll see that all the n's which are there in this code got converted into a. We just targeted all the n's and get converted into it. If you pass something like an x here, this won't get converted. I'll run this function again, this file again. So as you see, we just targeted n and n got converted into a. It didn't affect the x part of it. So this is a small, again, a small plugin, and just to this was included in the part in the task 2, just to make you understand like what are the different visitors. Like in the task 1, we targeted the call expression, and the second task we targeted function declaration. So these two tasks were just to give you a good idea what are the different visitors and how can you use path properties. third task is something interesting, and we'll convert our arrow function into a regular function. We saw something in the Babel introduction file, which I ran some time back. So I'll run it again for you just to give you a demo what we'll be doing. And it is really I think interesting task because this is something which Babel actually does, and we'll be doing it on our own. So if we run this npx, you can run it along with me in Babel, and so what happens is it converts that arrow function into a regular function, right? Babel, which is where sum is equal to function sum and return 1 plus 2. So this got converted into this. We'll be doing exactly this. We'll be converting an arrow function into a function expression. And so just to give you, this is our task 3. Open the task3.js if you're following along. And in this, we'll be, as you read the problem statement, in this Babel plugin, we'll convert an arrow function into an ES2015 regular function. So this, you might be thinking the code we'll be writing will be too big or something. It will be a little complex, but let me tell you, just 4 or 5 lines piece of code, and it is super easy to convert that arrow function into a regular function. So it's nothing complicated or fancy, but if you have a good hold on the theoretical part which I explained you, will be just able to do it in just 5 or 6 lines of code. So if you write function, oops, sorry, convert it to, okay, that's a big name, let's say convert function, right? You can name it anything as per your choice, and this is great. So now, as always, we'll return something, and we'll have a visitor object because we'll have to tell Babel where to act on it. Why do I put semicolon always? Yeah. So now, if we copy this piece of code and run it into our AST Explorer, we'll get to know where do we have to target. So if we see this, and if we see the arrow function, if you hover on the arrow function, it will highlight on the left hand side what is exactly the path which is included in the arrow function node. So so this is the arrow function expression. We want to target this arrow function expression and convert it into a regular function expression. Now we know we want to visit an arrow function expression, so our visitor would be arrow function. So we'll copy this arrow function, and in the visitor object we'll write arrow function. Right, the parameters would be path and state. Yeah, right. So we know we have to target the arrow function. Now the thing is, our function, this function has a few things in it, which is a parameter. If you see the parameters, if you hover on the parameters part, it has a parameters which are A and B. So if you hover on the parameters property, if you hover on the identifier 1, it will highlight on the A, and if you hover on the second, it will highlight B. So these are the parameters which should be there in the regular function. So we'll first extract these parameters, and there's a body as well. We want the body to be same. We just want to convert this arrow piece of code into a function with same parameters and same body. So we'll first extract these parameters and body because it will be easy for us to put them again into the regular function. We won't do much of a calculation there. So let me just extract those parameters and body first. So what we'll do is we'll do const, we'll do params is equals. Okay, we can do something like paths, paths dot node, right? So we'll get our params, right? We'll have our params now. Just a second. Yeah, we have our params, and we want our body. So the body is inside a block statement. Oh, the body is this, right? We want this same body exactly. We don't want to change anything in the body. So we can get the body with const body is equals to path dot node. So these are the two things which we have. So we have the parameters which will be same A and B, and we have the body which is same as console.log b and return 1 plus 2. So we'll be using these. Now what we want is we want to convert this arrow function into a regular function. So let me go to the Babel type documentation. So I'll show you how Babel types will be really useful in this case. So what we can do is uh, we'll check, we'll generate a function expression. So if we search on this page, function expression, so this is the arrow function expression. We want the regular function expression. So we'll go function expression, right? So what this does is it will generate a arrow, it will generate a function expression for us if we pass these properties, right? If we pass these properties, it will generate an AST for the function expression, which we want, right? We want to operate on our arrow function expression and convert it into a regular function expression, right? And we have these parameters, right? We have extracted the params, so we have params with us, which is this. We have body, which we extracted, so we have body. We can pass these two things. And async and generator is something which will be a boolean value if it's a generator function or not, and async is if it's asynchronous function or not. And the id can be null, the default will be null. So we have something in with us. We have params, we have body, we have we won't pass anything, we'll keep it false, and this will just give us the function expression. So if we do something like, we have already imported the types, so if we do types dot function expression, it will start suggesting its function. So function expression we'll pass. So the first parameter which we is id, we want id to be null, we can pass it be null. The second parameter which we have to pass is params, the params which are present in the arrow function. So we have already extracted the params, right? So we'll just pass params. And the third thing which we extracted is body, right? So we'll just pass body here, right? And you can keep other things false because the default value is going to be false and false. So you can just either mention it here or not mention it. If we keep it, it's fine. Yeah. So I think we are good to go. Okay, now, yeah. So we have generated this types.function expression. Now what we want is we want to replace this arrow, this whole arrow thingy with function. We want to replace, we want to just replace it. So path has a property called replace, right? We have not generated it, but we have not replaced it with existing code. If we just do this, nothing will happen. But we want to replace the existing path. We want to replace the arrow function path. So what we'll do is path dot replace with, what we want to replace it with, we want to replace it with a function expression which we just created now. So we'll just cut it and paste it here. What we'll do is we replace the path, the complete path, which is this, right? We'll replace it with a function expression which we generated just now. So if we run this, let me just run it, and like you can also run it along with me. Node src babel task3.js. So right, this converted a piece of code into a function expression. It is very similar to what we saw, what Babel did for us in the Babel introduction piece of code. It converted that piece of code into this, very similar to this. So this is something like which you can do. You can convert your arrow functions into regular function. And see, just how much line of code? 5 lines of code is there, right? Just move it to the one line, and it's very easy. Types has reduced a lot of code. You just pass types dot function expression and pass the parameters which are extracted, and you're good to go. This will just generate function expression for you. So it's very easy, right? This was a task 3. I have one more task, but I guess it's we are short on time. But I can just give you a small walkthrough what we can do exactly here. But it is something interesting which I've worked on. I've already generated a Babel plugin for it. I'll share a GitHub link so that you can get an idea what exactly is this. So we'll be creating in this task, we'll be creating a new syntax very similar to pair in C++ using Babel plugin. So if you have coded in C++, there's something called pair. And what pair does is, I'll just give you a small demo. This is something which is not there in JavaScript. So what pair does is, if you okay, this is not a good website. Just a second. Let's go to GFG. So yeah, you can do something like this. You can create a pair and you can assign different values to it. So the pair dot first property is 100 and pair dot second property is G. So it's like just a pair object, like the with the different properties in it, and you can access all of them with uh, pair one dot first and pair one dot second, right? And we'll be creating something very similar to this. This is not present in JavaScript, but yeah, if you have coded in C++, you will be aware about what exactly pair is. It's kind of a data structure with first and second property, and you can assign anything to it. You can reassign it. So part dot first is 100 and part dot second is G, and you can access it, change it however you want. So this is something like const train, and this is something like pair Delhi to Bombay. Okay, so the pair dot first prop. If this was C++, it would have been pair dot first is equals to Delhi and pair dot second is equals to Bombay. But this is not something which is present in Babel. So what we can do is we can convert this whole piece of code into an object. I'll give you. I think we won't be able to code this as we are already short of time. As the code for this is something big. It's a lot of code, but I can like just give you a code walkthrough so you can get an idea what exactly we are doing. So I'll be copying some code, the exact piece of code which I've already published it on my GitHub. So yeah, so so yeah, this is something like const car is equals to pair model and speed, right? So what we wanted it to convert into an object property, which would look something like const car. The first would be model and second would be speed. We wanted it to convert it into something like this. So we can access our car dot first and we can access our car dot second. So very similar to this, right? Converted that pair into an object with first and second properties. So I'll give you a code walkthrough what exactly I have done here. So if you copy this piece of code and go to AST Explorer, right? And if you hover on pair, it is a call expression, right? So we know we have to target the call expression to manipulate our AST. So this is something which we have to target. So I have targeted my, I've directly written my function here, right? So I have to target a call expression, right? And I have to check if it's a pair or not. Very similar to we checked if it's a console or not. So I have to check if type dot is identifier, the callee dot name property is pair or not. If it's pair, we'll continue it. Otherwise, we'll just nothing will happen then. So and now we have to check the arguments. So if you check the pair property, it has the argument object in it. This now it has two elements. The arguments are this model and speed. If the arguments are three, this then it makes no sense. Pair as means it should be two, and if argument is one, then also it doesn't make any sense. So first we are checking if the arguments, if we have arguments at all, and then if the number of arguments are not two, right, we'll just throw an error, and you can throw error with this throw dot path dot build code frame error, and we can throw an error like two arguments are required to make this work. Please check the number of arguments. And if they are just exactly two, we can continue this piece of code. And once we have extracted the first property and second property, the first property in this case is model, and the second property in this case is speed. So once we have first and second, which have extracted with the helper function, which is this, we'll replace the whole path, right? We want the same which we did in the arrow function. We'll replace the whole path with an object, and the object would have the first property, and the first property would point to the first, and the second property would be similar to second. So in this case, the first would be model, and the second would be speed. So if I run this code, we'll get something like node src babel task. Okay, I think it should run. Yeah, so we have this const car pair model and speed. It got converted into the first property with model and the second property with screen. So very similar to this, we extracted the first one and the second one, and we replaced the path with an object. So I think that's all for this. I think you got a good idea of different properties which we can use, the Babel types we can use to check, to reduce our piece of code to check if it's a particular type or not. We can generate a type which I showed you, like type.function expression. We can create function expression easily. I would have coded the fourth one completely, but I think we are short on time, but it would take some time. So I think that's all for this. Uh, I just wanted to give one small performance optimization in this. Reduce your traversal as much as possible, because this takes a lot of computation power, and every time traversing for the small things does not make sense. So make your code more optimized. Don't traverse on everything. They are very good ways to optimize your traversals, because traversing tree is a costly thing, and it will affect our performance a lot. So just consider the optimization part as well. Don't just traverse for anything. You can do a lot of things without traversing as well. I think that's all for it. And if you have any questions, like, we can uh, talk about it and like discuss it.
Hi, Apurv, Jason here. So there is a question in the chat. So if you can see, it's from Mukul. See if you can answer this.
I think as a conversation, can you demonstrate an example where I just want to display hello world within div tag in HTML? Considering the content of div tag is dynamically set as a return type from an arrow in my JS file, so I need to know how can I use Babel to transpile my JS code into all, just make it run in browser. So,
Uh,
Mukul, are you sorry, yes, Nitya?
yeah, I was saying like just see if it is relevant to the session, or if you want to answer this later on, you can also answer this later on.
Yeah, so I just wanted one clarification, Mukul. So are you asking, you want to dynamically change the content of a div to hello world, or what are you asking about? I exactly
Yes,
sorry.
hi Apu. So actually, the presentation that you have given today, you are transpiling all the Babel code into console. But you
Yeah,
know what I'm expecting is I want to write an HTML kind of a website, and I'll be using the modern JavaScript that is not supported by the browser. And I want to somehow use the Babel plugin that will transpile my JS code into Word.js, and that should work perfectly with the website.
yeah, yeah.
So that's all.
So, okay, you want me to demonstrate it. Okay, so I think that would not be possible right now, but yeah, I can like show you. Maybe I can send you a piece of code which would give you a
Yeah,
small, which would give you a good idea. Like, I've
that will work.
written a small plugin in React which manipulates the React code in it, that div inside React, and so you get a good idea. Maybe you can reach out to me on Twitter, and I'll share that link with you. It's a private repo. I'll share it with you.
That
Okay,
will be great.
that will be great.
Idea,
Yeah.
actually.
Thanks, Apu.
So everyone can follow Arup on Twitter, and have any questions, you can ask them. Ask Arup over there. Apu
Uh,
over there. Sorry. Okay.
yeah.
All right. All right. So I think
So
we are done with the session. Yeah.
yeah.
Oh.
Yeah, I just wanted to say there are a few important links. If you want to learn about more about Babel plugins, there's a Babel handbook which you can refer to. I'll share the PPT link. The PPT is not like it's restricted now. I'll open it to everyone. There's a one beautiful blog by Vedhi where she explains what exactly AST, parse trees, different things are. It's a good thing if you want to learn, if you deep dive into computer science, the core computer science thing. And it's a blog by Pan. Uh, where he explains about how you can write a Babel plugin. So all these resources are really useful. If you want to check them out, you can. And I'm really sorry, I just wanted to code the task 4 with you all, but couldn't do it. This is something which I created on my own task 4, the object one. But in case you face any difficulty, the GitHub repo is there. I'll share the link with you all for the GitHub repo for the task 4 which I've coded. But you can check out that code. And in case you face any difficulty, you can like always ping me. Oh, not this one. Yeah, so this is the piece of code. So I've written this. It's not fully optimized, but they are. It will work for most of the cases. In case you face any thing, you can like always reach out to me.
Okay, thanks, Apoorv. So a few days back also I was facing the same issue, but like in my some work, there was some requirement to replace something. So this kind of approach actually helps out. So in
Yeah.
my implementation, I just used the code mods which you have from Facebook. But yeah, this is much better because it's like a plugin and it has more flexibility and inbuilt features inbuilt into it. Yeah,
Right. Right. Yeah.
great way to refactor a legacy code also.
Yeah.
Okay. Anyone has any questions? So guys, please follow Apoorv on Twitter and ask questions to him. Anything you want to discuss on it, you can use Twitter for it. And Apoorv, thanks for this great session. Thank you.
Thanks a lot to everyone, Ikas, Neha, you, and Pratik for organizing and allowing me to have a workshop here. So thanks a lot. I hope you all liked it and learned something new. I'm sorry if I was not able to explain some part, but I'll
Right.
be happy to help you with all the doubts, and I hope you will understand it if there's any issue.
Yep, it was quite detailed, so yeah, it's pretty good. Okay, so I
Yeah,
will be putting this recording on YouTube later in the day, like
yeah,
by 12 o'clock night. You can check it over there if you missed something. And yep,
yeah, sure, definitely. Okay.
thank you for joining. Thanks, Apoorv.
Thank you so much. Thank you. Bye. Bye, everyone.
Bye, everyone.